Next up, this is question 1. When app migrate needs to move a Windows application to AWS. This application requires a shared Windows file system attached to multiple EC2 Windows instances deployed across several availability zones. What should a solutions architect implement? Select one answer. Review the answer choices on screen. The correct answer is option A. SMB protocol requirement that locks in FSX only. Amazon FSX for Windows File Server provides fully managed, highly reliable, and scalable file storage that is natively accessible via the Server Message Block (SMB) protocol. It's designed for Windows-based applications and can be deployed across multiple availability zones for high availability, allowing multiple EC2 Windows instances to mount and share the file system. Hey there, Stack Lessons here. Today's drill is 10 questions on auto-scaling strategies, Aurora cloning, and backup automation in DR. You know the format: question, countdown, reveal, explanation. 6 seconds is the default, but pause anytime. Let's get started. Keep score as you go. I will ask for your total at the end. Now, question 2. Classic exam trap. Messages Processes Inc. has an application on multiple EC2 instances processing messages from an SQS queue, writing to RDS, and then deleting the SQS message. They are finding occasional duplicate records in RDS, though the SQS queue itself has no duplicates. How can a solutions architect ensure messages are processed only once? Select one answer. Review the answer choices on screen. The correct answer is option C. DLQ and FIFO both miss the actual root cause. Duplicate processing can occur if a message becomes visible again in the SQS queue before the consumer finishes processing and deleting it, e.g., if processing takes longer than the visibility timeout. Increasing the visibility timeout using Change Message Visibility API or at queue creation to be longer than the maximum expected processing time ensures that a message is not redelivered to another consumer while it's being processed, thus preventing duplicate processing. Now, let's open question 3. App Performance Peak has an application on EC2 instances behind an ALB Auto Scaling group. On the first day of every month at midnight, a month-end financial batch runs, causing application slowness as EC2 CPU utilization immediately hits 100%. Disrupting the application. How can a solutions architect ensure the application handles this predictable peak workload without downtime? Select one answer. Review the answer choices on screen. The correct answer is option A. Known time on the calendar means scheduled scaling wins. Scheduled scaling actions in EC2 auto scaling are designed for predictable load changes. Since the financial batch run occurs at a known time, first day of the month at midnight, a scheduled action can proactively increase the number of EC2 instances by adjusting desired min-max capacities before the batch starts. This ensures sufficient capacity is available to handle the increased load, preventing CPU saturation and application disruption. Another scheduled action can reduce capacity after the batch window. Let us keep moving. Question 4. Check the condition before the service. Sensitive Data Store, Inc. is storing user information in an S3 bucket and needs secure access from an application tier on EC2 instances within a VPC. Which 2 actions should be taken? Choose 2. Review the answer choices on screen. The correct answers are option A and option C. 2 of the 5 are hard security anti-patterns to eliminate. A gateway VPC endpoint for S3 ensures that traffic from the EC2 instances to S3 remains within the AWS private network, not traversing the public internet. C An S3 bucket policy can further secure access by allowing requests only if they originate from the specific VPC endpoint or the VPC itself. This, combined with appropriate IAM roles for the EC2 instances, provides a robust and secure access mechanism. Now, let's get into question 5. Quick check. App Resilience Corp wants to migrate an existing on-premises application to AWS, ensuring high availability and resilience. The current application recently suffered data loss when a database server crashed due to a power outage. The AWS solution must avoid single points of failure and scale to meet user demand. Which architectural approach best meets these requirements? Select one answer. Review the answer choices on screen. The correct answer is option A. Both tiers need AZ redundancy, only A covers both. This solution addresses both high availability and scalability. Deploying EC2 instances in an auto-scaling group across multiple availability zones, AZs, ensures the application tier can withstand an AZ failure and scale based on demand. An Amazon RDS DB instance in a multi-AZ configuration provides high availability for the database by maintaining a synchronous standby replica in a different AZ with automatic failover. This combination avoids single points of failure for both compute and database layers. 5NF SX owns SMB, visibility timeout is the SQS duplicate culprit, and multi-AZ must cover both compute and database layers. Time for another one. Question 6. Map the qualifier to the answer. Batch Predict Corp has weekly scripted batch jobs on EC2 instances in an auto-scaling group. Transaction numbers vary, but baseline CPU utilization is at least 60%. Capacity must be provisioned 30 minutes before jobs run. Engineers currently modify ASG parameters manually. An automated way to adjust desired capacity is needed with least operational overhead. What's the best solution? Select one answer. Review the answer choices on screen. The correct answer is option C. Weekly repeating jobs are exactly what ML forecasting learns. Predictive scaling in EC2 auto-scaling uses machine learning to forecast future traffic, including regularly scheduled peaks like weekly batch jobs, and provisions the right number of EC2 instances in advance of predicted changes. By configuring it to use CPU utilization as the metric and setting a pre-launch time of 30 minutes, the capacity will be automatically available before the jobs run. This automates the manual process and is more proactive than reactive scaling policies for predictable workloads. Let's break down the scaling decision, because the difference between reactive and predictive really matters here. Imagine your batch jobs fire up every Monday morning at 9 a.m. sharp. Step scaling watches CPU climb, then triggers, but by then you're already behind. Predictive scaling flips this around. It looks at your last few weeks of CPU data and spots the pattern automatically. Then it pre-launches instances 30 minutes before the spike. So when your jobs kick off at 9 a.m., the capacity is already warm and waiting. That's the key. Reactive scaling always plays catch-up. Predictive scaling plays ahead. For any workload with a regular schedule, predictive wins. It's automated, proactive, and you never touch the auto-scaling group manually again. That's why C beats A, step scaling reacts, predictive anticipates. Time for another one. Question 7. Ignore details that do not change the decision. DB Migrate Solutions is moving an on-premises application with a MySQL database to AWS for better elasticity and availability. The current architecture experiences heavy read activity. Every 4 hours, a full production database export for staging causes unacceptable application latency, and developers cannot use staging until it completes. A solutions architect needs a replacement architecture that resolves latency and allows uninterrupted staging environment use. What is the best approach? Select one answer. Review the answer choices on screen. The correct answer is option A. Cloning, not snapshots, not exports, is the key unlock. Amazon Aurora MySQL provides high performance and availability, with Aurora replicas handling read traffic efficiently. Aurora's database cloning feature allows for fast creation of a new database cluster for staging from an existing one, typically in minutes, without impacting the production workload. This directly addresses the latency issue during export and allows developers to use the staging environment quickly. This one is sneaky. The cloning detail is what separates Aurora from a plain RDS answer. Imagine your team refreshes staging every 4 hours by dumping the whole database. Production crawls. Developers wait. Here's what Aurora changes. First, Aurora replicas absorb the heavy read traffic. The main writer stays fast. Then, when staging needs refreshing, you trigger a clone with a single API call. Aurora uses copy on write. The clone just points at production storage. No data is actually copied up front. Only when something changes does Aurora write a new page. That means even a 2 terabyte database clones in minutes, not hours. Production never slows down. Option C, RDS with nightly snapshots, still makes developers wait. The exam rewards Aurora's clone feature. That's why A wins. Ready? Question 8. Watch for must, most, least, or except. IoT Mattress Data Inc. is releasing a smart mattress with sensors that collect data about a user's sleep patterns. These sensors will send data directly to an Amazon S3 bucket. Each mattress is expected to generate approximately 2 megs of data every night. The company needs to process and summarize this data for each mattress individually, and the results of this processing need to be available as soon as possible. The data processing task itself will require about 1 GB of memory and is expected to finish within 30 seconds per mattress data file. Which data processing solution will meet these requirements most cost effectively? Select one answer. Review the answer choices on screen. The correct answer is option D. Per file with 0 idle compute, Lambda's ideal billing profile. AWS Lambda is an excellent choice for event-driven, serverless processing of individual data files like this. By configuring S3 event notifications to trigger a Lambda function upon each new file upload, the processing can start almost immediately. Lambda functions can be configured with a required memory, 1 GB in this case, and have a maximum execution time of 15 minutes, far exceeding the 30-second processing time. This approach is highly cost-effective because you only pay for the compute time consumed when the Lambda function is actually running, processing a file, and it scales automatically with the number of incoming files without any server management. Ready? Question 9. The answer hinges on one qualifier. CloudFormation SecureDB uses an AWS CloudFormation template to deploy a 3-tier web application. This application consists of a web tier and an application tier, both hosted on Amazon EC2 instances. These tiers store and retrieve user data in Amazon DynamoDB tables. The database tier, DynamoDB, is not publicly accessible. A critical security requirement is that the application EC2 instances need to access the DynamoDB tables without exposing any API credentials, access keys, directly within the CloudFormation template or on the instances themselves. What should the solutions architect do to meet these secure access requirements? Select one answer. Review the answer choices on screen. The correct answer is option D. Never store credentials. The instance profile handles everything. The most secure and AWS recommended method for granting EC2 instances permissions to access other AWS services, like DynamoDB, is by using IAM roles and instance profiles. An IAM role is created with an IAM policy that grants the necessary permissions, e.g., wget_item, why_put_item, on specific DynamoDB tables. This role is then attached to an EC2 instance profile. When the EC2 instances are launched, as defined in the CloudFormation template, this instance profile is associated with them. The EC2 instances can then automatically retrieve temporary security credentials from this role, allowing them to securely access DynamoDB without needing to store or manage long-term API credentials within the template or on the instances. Let us switch gears. Question 10. The trap is partial correctness. Multi-region EC2 Backup Corp has migrated multiple Microsoft Windows Server workloads to Amazon EC2 instances that currently run in the US West 1 region. The company has been manually backing up these workloads by creating Amazon Machine Images, AMIs, as needed. In the event of a natural disaster affecting the US West 1 region, the company needs a strategy to recover these workloads quickly in the US West 2 region. The recovery point objective, RPO, must be no more than 24 hours of data loss on the EC2 instances. Additionally, the company desires to automate the backup process for these EC2 instances. Which two AWS solutions or features will best meet these backup automation and cross-region disaster recovery requirements with the least administrative effort? Choose two. Review the answer choices on screen. The correct answers are option B and option D. DRS is overkill. Scripts violate the least admin requirement. B. Amazon Data Lifecycle Manager, DLM for EBS snapshots, which AMIs use, can automate the creation, retention, and deletion of snapshots in AMIs. You can create policies to take backups based on tags, schedule them, e.g. twice daily to ensure a 24-hour RPO, and configure these policies to automatically copy the created AMIs or underlying snapshots to another region like US West 2. This automates the process with less administrative effort than manual scripting. D. AWS Backup provides a centralized and automated way to back up various AWS resources, including EC2 instances. You can create a backup plan, target instances using tags, schedule backups, e.g. twice daily, and configure cross-region copy to US West 2. This also offers a managed solution with minimal administrative effort. Both DLM and AWS Backup are effective for this. The choice might depend on whether a broader backup strategy across multiple services is being implemented, favoring AWS Backup, or a more EC2 EBS-focused one, where DLM is also very suitable. Hang on, there are two correct answers here, and understanding both will lock this concept in. Imagine your boss says, 50 Windows servers, daily backups, cross-region, 0 humans involved. AWS gives you two managed tools for this. Data Lifecycle Manager, DLM, is EC2 and EBS focused. Tag your instances, set it to fire every 12 hours, and it auto-copies the AMI to US West 2. AWS Backup does the same but wider, 40 plus AWS services, all managed in one place. Both automate tag-based backups and cross-region copy, and both schedule tight enough to keep you inside a 24-hour RPO. Trap A. Writing your own scripts adds the maintenance overhead this question is trying to avoid. Trap E. S3 cross-region replication cannot touch EBS volumes at all. The question rewards the two managed services, not the manual approach. 3 takeaways from this session. First, Aurora cloning uses copy on write to deliver a staging database in minutes with 0 production I/O impact. Second, SQS duplicate records trace to visibility timeout expiring before deletion, not to a queue-level bug. Third, both DLM and AWS Backup automate cross-region AMI copies. Choose backup when protecting multiple resource types centrally. You've drilled all 3 scaling modes, Aurora's copy on write clone trick, and the DLM versus backup split. These patterns punch above their weight on the real exam. Replay the deep dive as on anything that felt shaky. One quick thing before the next set. Subscribe if these are making your prep easier. It keeps them free and helps new students find them. Comment your score. I read every one. If you'd like a different exam covered, suggest it below. And if the pacing or the visuals could be better for you, let me know your thoughts.